Hi guys, and welcome to iNiro. In this video I'm going to show you two new features I've just released, which are related to context, memory size and token consumption. And they actually have the capacity to reduce your token consumptions using Magic Cloud by 85%. Input tokens, specifically, I need to emphasize. So let me first demonstrate this, but I need to emphasize this is a little bit difficult to demonstrate because the process is 100% automatic and it's automatically happening in the background. You never need to think about it. You never need to do what I'm doing here. What I'm doing here is just to illustrate how the process works. So, but let's first just say hi to this guy, at which point something interesting pops up in the bottom right corner here. This is in 7098, out 13. These are input tokens, and yes, I am trying to reduce the system message, and these are output tokens produced by the LLM. Now, I want to pollute my context with lots of rubbish data, right? Use the hyper lambda generator and execute the following prompt. Crawl and scrape the first 5 pages. Actually, let's do 10 pages. You find at hyperlambda.dev/sitemap.xml and return the complete HTML. Do not show me neither the code nor the results. I am simply seeding your context. Now when I click send, it's going to immediately pop to input tokens like 14,000 or something. But then after the scraping process is done, the threshold in context increasement for every single consecutive message is going to be like 100,000 tokens. And that is kind of like the point. And at that point, I want to compress the memory to show you the effects of the context compression. So this prompt, the prompt that's doing this is actually consuming GPT 4.1 mini, and it's actually based upon Anthropic's dream prompt, because the way the human brain works is that as we are dreaming during the night, what is happening is that we are rearranging memory, similarly to how the LLM is rearranging its memory now. Now, if I say, hello, watch my context input tokens here, 111,000, 201,000. That simple hello costed me almost 100,000 input tokens. Right. Now, let me show you how memory compression works. Search for memory compression using get context and execute it. Now at this point in time, remember our current context window size is approximately 100,000 tokens because we got 10 HTML pages from freaking hyperlambda.dev in our memory, right? So I mean, we're like throwing tokens down the toilet here, right? Now 382,000, 473,000, now, hello, 473 to, remember we had almost 100,000 token increasement for every single message before the memory compression part. Look now, and we still have it. Hi, 563, 654, do memory compression now. 654,000, 661. We just got rid of 80% of our tokens, more than that, 85%. So we reduced the context token window size from 110,000 tokens down to like 15 to 20,000 tokens. That's a reduction of 85%. I need to emphasize this process is happening 100% automatically. You never have to do what I did, and what I did is actually really, really difficult. And that's why we call it the dream prompt, because it's just like happening automatically in the background. The way it works, let me show you exactly how it works by going here to machine learning and finding the specific type I was actually using. This is the type that I was currently using. And as you can see here, it's got max session items of 25. When I reached 80%, of that, implying I got like 21 messages or more in my context. Automatically what will happen, the entirety of the context is transmitted to GPT 4.1 mini with a very specific system instruction that tells it how to compress its memory. Let's have a look at it if we can find it, if I can remember where it is. I think it's in system files. Let me see, system, OpenAI, and Dream prompt system message. Here you can see my system message, the GPT 4.1 mini. And this message has been extremely tuned and optimized, and it's actually based upon the same thing that happens in your brain at night when you are dreaming. This is the stuff your brain, purely from a logical point of view, does during the night, and that's why we call it a dream prompt, right? So anyways, thank you for watching. Have a nice day.